Greetings, ladies and gentlemen, boys and girls. Today I'll be conducting a tour of Arduino Park, an exhibit of the open-source electronics prototyping platform built on a scale of approximately 1,000 to 1. To quote Wikipedia, the Arduino project began in Ivrea, Italy in 2005 to make a device for controlling student-built interaction design projects less expensively than other prototyping systems available at the time. Arduino is Italian for strong friend. We're standing on the western, or as some people like to call it, the left-hand side of the Arduino. The silver box-like structure behind me is the USB port which connects to the user's computer for receiving and transmitting programming and data. The black structure that I'm facing is the DC power jack, which can be attached to either a power supply or a battery pack so that once programmed, the Arduino can be detached from the computer and put on the go. We'll now head into the heart of the circuit board. See, I told you we could all easily get up here by climbing on one another's shoulders. We're now on top of a crystal timer chip whose rapid, steady heartbeat provides the clock input that regulates the microprocessor. Around us are many other small components which we won't discuss today, but they serve very important functions in implementing input and output between the world and the microprocessor chip, which is the real brain of the microcontroller. Eastward ho! Hey, the sun must have come out. It's not as if someone finally remembered to render shadows. The giant black centipede looming behind me is the ATmega 328P-PU microprocessor chip. It's the brains of the Arduino, in which all the logical and arithmetic calculation is done. Say, where's the dog? The black towers on the edge are called headers. When building a circuit, you stick wires in the holes in the top, and they connect to the microchip without messy soldering. Where we're standing now could be called Power Street, because these holes can provide power for your circuit from the Arduino. Arduino voltages are quite harmless, but here at Arduino Park we scaled them up a bit. Just don't touch anything shiny and you won't have to recomb your hair. This collection of header holes could be called analog alley. Say you have a sensor. It could be a light sensor or a temperature sensor or whatever. The point is the sensor data isn't just 0 or 1, high or low. It's a gradient of values. That's analog data for you. And if you want Arduino to read it, this is where you connect it. Please watch your step around that well. I forgot to bring the rescue rope. The 6 golden prongs at the edge of the board are for connecting to what are called shields in Arduinoese. Shields are additional circuit boards which add capabilities such as communications to your basic Arduino. I'm now standing on the reset button, which does what the name implies, but sometimes you have to stomp really hard. Well, for here that is. On a regular Arduino, stomping is not recommended. The header towers here might be called digital lane if you're not yet tired of road metaphors. Each connection atop the headers can be programmed for digital input or output. The little tilde marks next to pins 3, 5, 6, 9, 10, and 11 indicate that they can be programmed for PWM, which stands for pulse width modulation, and despite the similarity to PWN, has nothing to do with inflicting humiliating defeat on your adversary. As for what PWM does do, it can provide light dimming and motor speed control through digital outputs. If you can think of ways for those things to inflict humiliation upon your adversary, go for it. Moving on, or actually, we'll just stay here. Where I'm at, these orange rectangles are built-in LEDs. When a signal is received from the computer, the RX LED flashes. You should have seen the dog jump the first time he was there. Anyhow, the TX is for transmit, as you might guess. The L LED that I'm on happens to connect to the I/O pin 13, which means you can test the circuit without having to insert an external LED. Although some people still insist on using an external LED. Well, folks, that's the end of our tour. Thanks for coming along, and be sure to check out the larger-than-life Coliseum exhibit next door, which is very similar to the original Coliseum in that it doesn't actually do anything, and by comparison you'll find that playing with an Arduino is even more exciting, which I hope you'll now be inspired to go right out and do. Remember, no matter how big or small they are, Arduinos are fun.